Okay, thank you very much for joining us, and thank you especially Mr. Edgerton-san, thank you, and thank you very much for Lynette Chung-san, thank you very much. So, and our topics is circular economy implementation, and so I will start the session. So. Would you please project my slide? Okay. So I'd like to use probably 3 minutes or so. And what is circular economy? The next slide. Here. And so briefly, here's a history of circular economy. And probably the first message is December 2015 from European Commission. And that closing the loop is a concept. But in Japan, circular economy was explained as an extended form of recycling or reuse. And I think it's a very simple misunderstanding of circular economy. So, and this is some comparison of graphic presentation of circular economy. So linear economy is quite simple, and the recycling economy, that's in the middle. And so raw material production and consumption, and some recycle, but some at the final stage waste. So this is current status in Japan. And the circular economy means something like the right figure. So raw materials come in, and the production, and the consumption, and the recycle, and the rotation. So there's no waste, is this figure says. But this is a little bit different circular economy definition, I think. And right side figure, there's no input at all. So circular economy that make, use, recycle, then no input, make, use, recycle. That's a no input, no disposal. So I would say that circular economy definition is not fixed yet. So probably, definitely this is the most advanced style of circular economy. So, and well, I would like to add one more thing. So this is global risks by World Economic Forum 2020. But there's no something happens in the deficiency of resources. I think it must be included here. What do you think about it? So later I'd like to ask each person. So this is a very brief introduction of myself. And first I'd like to invite Mr. Brendan Edgerton. Would you go and make your presentation, please? Please.
Hello, everyone. My name is Brendan Edgerton, Director of Circular Economy for the World Business Council for Sustainable Development, headquartered in Geneva. I have the privilege and honor of speaking with you today about circular economy in the private sector. And I'd like to first extend my appreciation to the organizers of ICEF2020 for inviting us to be part of this concurrent session. First, an introduction to WBCSD. We are a global CEO-led organization of over 200 leading businesses working together to accelerate the transition to a sustainable world. We are the leading voice for business in sustainability, and we are united by our vision of a world in which more than 9 billion people can live well within the means of the planet by 2050. And we use our global network of almost 70 national business councils, and they work with us on a number of different projects and programs and implementation across the globe. And shift to circular economy. So the state of global circularity today, the reality is that we are only 8.6% circular. That's actually down from last year when we were 9.1% circular. We have and continue to consume resources at a glaring pace. Our global resource use, material demand per capita, and material productivity are all increasing over time. And what what you see here is that global resource use has more than tripled since 1970. That global material demand per capita has grown from 7.4 tons to 12.2 tons between 1970 and 2017. And then lastly, that material productivity started to decline around 2000 and has since stagnated. So although the original assumption is that as technology improved, as innovation improved, that our material productivity would also grow, that in fact has stopped happening in the early 2000s, and in some cases actually declined globally. And when it comes to the consequences of this resource consumption, we see that extraction and processing of materials, fuels, and food are responsible for 90% of the biodiversity loss we have today, 90% of water stress, 50% of greenhouse gas emissions, and 33% of the pollution and health impacts. In taking a step back and looking at 2020, obviously the tremendous impacts on the global economy as well as individuals and society that COVID-19 has had, you can argue that this is not helping the pursuit or transition towards a circular economy. And here are a few different trends that suggest as much. So the first is on personal equipment, the PPE that is talked about and is so necessary for the response to COVID-19. For example, all mass produced to date and planned would cover the country of Switzerland. So obviously this is a brand new waste stream that wasn't created nearly at the pace of previous years, but given the importance of face coverings in the COVID-19 environment, this is a very large material stream and unfortunately waste stream that's popping up. Another implication is the global slowdown has triggered an unprecedented drop in demand and price of oil from these containment measures, and some are even beginning to say that we have seen peak oil consumption. However, what this does result in is a very competitive landscape for recycled oil-based products and materials such as plastics, which makes it very difficult for companies to consider using recycled plastics when the price of that is much higher than those virgin oil prices. The third is on takeout and delivery. Of course, many of us are now consuming food much more in this way than we had before in many cases. And 2020 is actually on pace to have 30% more waste generated than 1 year prior. And much of this, unfortunately, is due to the takeout and delivery trend we see. And lastly, obviously, another big change is on e-commerce. People buying things online. It's much safer to shop from your bedroom or your living room than it is from retailers and grocery stores in some cases, and certainly than it was a few months back. But as a result, this e-commerce, the growth in that is expected to be 20% this year over last year. And with e-commerce comes new packaging, comes new secondary and primary packaging to that point. So it can be more resource use and ultimately more waste that's generated. So what's the opportunity? How can we change things, and how can the private sector help drive this transition? We argue as WBCSD that the circular economy creates a great opportunity for companies to not only do well, but to do good at the same time. And to do this by decoupling their resource consumption from their financial performance. And so a couple of years ago, we published for the first time a CEO guide to the circular economy. And this was a document that put this discussion at the top of the business agenda and highlighted those leading companies that were already thinking about circular economy at the time and giving an introduction of what they can do in order to get started on their circular transition. We've since translated into Japanese, which you see a graphic here, and you can feel free to download the CEO Guide to Circular Economy in Japanese following the QR code in the upper right-hand corner. You could also find it in the slides when they're available afterwards at the link down at the bottom right. And we figured in understanding why companies are moving towards circularity, yes, it does have environmental benefits. Yes, it does encourage companies to think about their business model in a different way. But there are 8 different reasons why companies may shift towards circularity, and some could argue there's even more. And these fall into 3 categories of accelerating growth, enhancing competitiveness, and mitigating risk. I won't go into each of these 8 business cases. But you'll see the link at the bottom right that you'll be able to follow that to a specific publication that outlines those different business cases, as well as 16 examples from companies of WBCSD's membership that are already heading in that direction. To give you an idea of how companies move towards circularity, we found in another study that is known as the New Big Circle publication we did with BCG, that there are 3 phases in which companies take on circular business models of increasing advancement. The first is on process innovation. How can they reduce waste, conduct pilot projects on perhaps a product, but most of the time looking at how they can do a little bit better through their operations. The second is on this product innovation. So how do we design things differently? How do we include different materials that may be more circular themselves? And lastly, on the business model innovation, this is obviously the most challenging, the most involved, and requires the most collaboration, not only across your company, but with others along the value chain. And as a result, it is often the last circular strategy that is employed. However, it offers the most opportunity, economic, environmental, to the company itself. As the conversation has matured within circular economy, as does a company's wish to measure their circular performance. And in response to that, we developed the circular transition indicators and published them in January of this year to provide companies a consistent way to measure their circularity in an objective way based on quantifiable data. And we developed this, or co-developed this, with 25 companies within our membership across different industries and geographies. And due to the interest we're seeing about it globally, we're happy to announce that we will be publishing a Japanese translation of the Circular Transition Indicators version 1.0 on the 7th of October 2020, so the first day of the main event of ICEF 2020, and you'll be able to actually go to the link at the upper right-hand side and register to receive your free copy when it's available in just a couple weeks. So with that, I'd like to thank you for having me and welcoming WBCSD to the conversation. We hope you'll take a look at these resources and find them helpful, and we hope to hear from you in the near future. Thank you.
Okay, thank you very much. And you finished just 8 minutes. So thank you very much. So the next speaker is Dr. Dohi. Would you please go ahead?
I'd like to talk about transition to a circular economy. My name is Dohi. I am in charge of making strategy and planning project for innovation in NEDO. Before the main topic, let me introduce NEDO. NEDO is the largest R&D funding agency in Japan. Our missions are to address the energy and the environmental problem and to enhance industrial technology. We formulate the project and its frameworks by combining the industries and many R&D institutes. Based on this experience, I would like to show some viewpoints in order to think about transition to the circular economy. First of all, I'd like to share the gap between the current situation of technology and our goals on climate issues. The left figure shows the marginal abatement cost, MAC, estimated by 3 institutions, IEA, IPCC, and RITE. The curve in the figure is derived from the curve fitting using all these plots. The marginal abatement cost increases exponentially with the reduction amount. MAC is reaching around $1,000 per ton CO2 for a 40 gigaton reduction of GHG. This prediction is based on the implementation of only proven technology. The right figure shows additional costs obtained by the integrating MAC cap on the left. The additional cost of 40 gigaton reduction would exceed $10 trillion per year globally. This amount is equivalent to the 12% of the world GDP. Now we have shared how difficult it is without innovation. In the next slide, I'd like to consider the conditions of the social implementation. The blue line in the figure shows the MAC cap using existing technology, and the red line shows the reduction of the abatement cost as a technology development. One of the conditions for the social implementation is that the abatement cost of target technology must be lower than MAC cap of existing technologies. Our goal is to reduce MAC to a level acceptable to a society by promoting a lot of innovation. In order to achieve these goals, we designed the future vision for the sustainable society. This picture shows the basic idea. The idea is to accelerate the implementation by integrating three social systems: circular economy, bioeconomy, and sustainable energy supply. In order to do so, broader view of technology is required, and the abatement cost is useful as an indicator for this purpose. I would like to add that LCA-based abatement cost will become more important in the future. This will be introduced at the end of this session by Tahara-san. This sheet is a summary of the timing of the implementation based on the abatement cost calculated from the current R&D status. This was used in the concurrent session on CCUS at ICEF last year. This table shows the technologies related to the CCUS organized by the sector and implementation time. Technology on the right side require longer time for implementation. In the chemical field, plastic recycling has already been implemented. This implementation is not only plastics but also metal industries. Many technologies related to circular economy are expected to be implemented relatively early. NED has already developed several technology strategies for circular economy, and we are promoting related projects. This bubble chart shows our basic concept of recycling-related technology strategies. It is a little complicated, but it shows the current status of various materials in Japan. For a resource-importing country like Japan, it is very important to secure a stable supply. A weighted Vidal index is used as a risk indicator for security and is shown on the horizontal axis. The vertical axis shows CO2 emission on a low scale. The bubble side is sales. The rightmost plot shows a high risk for a stable supply. This is critical materials. Therefore, we set our technology strategy in 2015 and started the project in 2017. The high CO2 emission is the steel industry, brown big bubble. However, a recycling system for steel is already in place. Our next focus was on plastic, blue bubble. Plastics have relatively high security risk, high CO2 emission, and high sales volumes. It is also attracting global attention. Its strategy was set in 2018 and the project started in this year for a high-efficiency plastic recycling system. Aluminum is of particular interest because of its high CO2 reduction effect through the recycling. A pilot study has been started this year. Next, I'd like to introduce some of these ongoing R&D projects. This is a project on rare metals. The goal is to promote urban mining concept that helps a stable supply and resource energy conservation. In this project, 3 technologies are developed: automatic sorting, high-efficiency smelting, and information technology for the system. This is a project for plastic recycle, including the sorting, mechanical recycle, chemical recycle, and energy recovery. The important concept is to find the optimal treatment system for the waste plastics according to their quality. The last one is the demonstration project. This project aims to achieve an energy saving, a stable supply, and GHG reduction through the recycling system in Asian region. The project provides a know-how for partner countries. I'd like to close my presentation with this summary. Reducing 80% of GHG emission with proven technologies, marginal abatement cost would become around $1,000, and total additional cost exceeds $10 trillion each year globally. The role of innovation is to bring these costs down to a level that is acceptable to society. Innovation should be evaluated across the sector and fields. Transition to a circular economy is expected to be a promising CO2 reduction strategy in many industries. NEDO will continue to contribute to climate issue by promoting the development of circular economy-related technologies. Thank you for your attention.
Okay, thank you very much. And so the next speaker will be, excuse me, a little bit, Ms. Lynette Chung. So would you go ahead? Would you please go ahead?
Hi, everybody.
Okay.
My name is Lynette Chung. I'm very happy to be here with you and present the business model case study in the circular economy implementation session of ICEF2020. I am the Chief Sustainability Officer of Covestro, a global and leading player in high-performance plastics with a very strong focus on innovation and sustainability. The company in May earlier this year announced its new vision to become fully circular. My intention for today is to share with you a bit about our endeavors. Let me first briefly introduce you to Covestro before we deep dive into circular economy. Headquartered in Germany, Covestro has around 17,000 employees. It has a large product portfolio of different high-performance plastics, a global reach with around 30 sites and a 12 billion euro turnover. We serve various markets, such as automotive, construction, electronics, healthcare, and high-tech industries, to name some of them. Moving into the topic of circular economy, at Covestro, we believe that the circular economy must become the new guiding principle in society. We need to move away from the produce, consume, throw away approach and become circular and more sustainable. The global challenges of today, climate change, scarce resources, population growth, just to name a few, require us to do so, and we need to fundamentally rethink approaches. We need to set up more sustainable consumption and production patterns, avoid waste as much as possible, stop wasting, burning, or losing carbon without recovery, and establish enduring value creation cycles. Plastics play a key role to overcome the challenges and to deliver solutions. Plastics is essential to drive a resource-efficient circular economy. It is essential, for example, in lightweight vehicles for sustainable mobility, energy-efficient buildings, and renewable energy. We believe that the plastics industry can and must support the change to a circular economy because we are a resource-intensive industry with a rather high environmental footprint, and we have a high influence and leverage being supplier to many key industries. As guided by its vision, Covestro is embedding circularity throughout the company. We want to become a shaping force for circular economy and to contribute to a greenhouse gas neutral economy. We believe a well-defined long-term approach to circular economy is the necessary path to go and have launched a strategic program. To this end, we will focus on 4 strategic areas. Enhance the use of alternative raw materials in order to break away from crude oil. Strategically develop more circularity-inspired innovations in our product portfolio and foster recycling through innovative new processes. Strengthen our existing partnerships and building new value-creating circular economy partnerships and use renewable energy in our production. Imitating nature. Moving from a linear to a circular production requires efforts throughout the value cycle. Built next to the tree on the right-hand side, the plastic manufacturing value chain is pictured with its base in using fossil feedstock, such as oil and gas. To break away from the use of fossil resources, we want to, similarly as nature, focus in using what is already out there, available in our economy or nature. As trees use sunlight, we aim to use renewable energy. Carbon, as a plastic building block, should be recycled and come from alternative sources such as end-of-life materials, waste, biomass, and carbon dioxide. We are also developing new recycling technologies like chemical recycling to aid the recycling of plastic waste that is not suitable for mechanical recycling. On carbon dioxide utilization, Covestro has, together with partners, developed a breakthrough technology platform that enables the use of CO2 for producing important plastic components. We today have such plastic components called polyols available with up to 20% of carbon dioxide. These are produced in a special plant in Dormagen in Germany and marketed under the brand name Cardion. Use cases of Cardion can already be found in soft foam for mattresses, elastic textile fibers, and now also in automotive application. For us at Covestro, at the end, it is all about getting the most out of carbon, be it through waste, biomass, or carbon dioxide. Shifting to a global circular economy is a large-scale project that can only be achieved through collaboration. Society, businesses, and governments will have to cooperate across borders and continents. Different industry sectors must join forces, and within these sectors, individual players will have to work together to find and implement practical new solutions. With its circular economy program, Covestro strives to play a part in enabling the collaboration that will drive global sustainability forward. An example is on digital circular economy services. Transparency in the value cycle is key, and digital services can help all players to close loops. In order to ensure efficient and sustainable recycling of the plastics separated by type, the origin must be traced back to the raw materials. A consortium of the partners Circularize, Covestro, and Domio Chemicals has developed a solution to track the origin of the materials and intends to set a new sustainability standard in the plastics industry by introducing material passport using blockchain technology. Open standards is key here. Another example is our closed-loop partnership, where we aim to collect and recycle 1 million bottles every year and give them a new life in high-performance applications, for example, in the automotive and electronics industry. To conclude, Covestro's vision is to become fully circular. We will do this through breakthrough innovation, joined forces along the value cycle, and be powered by renewables. It is a big endeavor, but with a vision and a strategic program in place, we are going to step by step realize our objective to become a shaping force for the circular economy. Thank you very much for your attention.
Okay, thank you very much. And so the final speaker is Tahara-san. Would you please go ahead?
Good afternoon. My name is Kiyotaka Tahara from AISD Japan. Today, I'd like to talk about the importance and limitation of LCA in circular economy and the challenges of LCA. First, I'd like to show the basic LCA model that compares waste disposal and recycling. The left side shows the environmental impact of the disposal process, while the right side shows the environmental impact of the recycling. Although the recycling process in yellow may have a higher environmental impact than the disposal process in orange, the net benefit became lower because the produced recycled material will avoid new virgin material production in green. Please note this just an image, and the detail will change depending on the type of the waste and how it is proceeded. This figure shows the net benefit shown in the previous slide. This is a study done in Australia that shown the benefit of the recycling for the greenhouse gases, cumulative energy demand, water use, and solid waste. We can see the metal recycling generally has a large environmental benefit for the all impact categories. Recycling also avoids the occurrence of the solid waste for the all materials. This table is taken from an OECD report that shows the environmental benefit of the remanufacturing. We can see that remanufacturing reduces the overall use of the energy for the wide range of the products, such as photocopiers, computers, compressors, engine to the furniture, and clothing. Some studies also report that changing in the resource extraction, GHG emission, and the amount of disposal waste. And we can see that remanufacturing has benefit for those impact categories. Next, I would like to introduce the LCA result of plastic recycling in Japan, which I chaired. MR is material recycle, CR is chemical recycle, ER is energy recovery. We can see that energy recovery has an equivalent benefit to MR and CR depending on the conditions. We can also see from this graph that chemical recycling that produces ammonia from the plastics has the largest benefit. It may see that we should promote this chemical recycling method more, but there are various types of the plastic waste, and not all the waste plastics wastes can be recycled with these technologies. So far, I have shown example of the CE that produce a benefit, but in some cases there are examples where there is no environmental benefit or even worse. There are many other examples of LCA, such as Product Services System, PSS, and Sharing Economy too, but I will skip them due to the time limit. Next, I would like to briefly introduce some of the challenges of LCA in this field. In LCA, environmental impacts are measured based on the things called the function unit. It is especially difficult to set this function unit for CE. I want to explain the problem of this function unit by taking a computer as an example. If you set the function unit of the computers as one computer used for 3 years, if you use it for the 6 years, the function unit will be doubled. However, if we change the question and ask the consumers what is the value of the computer is, as shown in the orange area, the value of the computer decrease year by year. Extending the period of the use does not provide the same value to the customers as the function unit does. And this shows that we have a problem of comparing the things that are not equal. In one of our case studies, we asked 3,000 people how would rate the value of the computer you are using compared to when you first bought it. As you can see in the figure above, even though the dots are dispersed, there is a clear trend that the subjective value of the computer is depleted as time passes. In the real world, we must also look at the indirect effect. In this graph, the horizontal axis is the environmental impact and the vertical axis is in the cost. The blue arrow CE action indicates the case where the implementation of the CE has reduced environmental impact and the cost at the same time. As we have seen, there are many LCA case studies that evaluate these blue arrows. However, if the next activity, orange arrows, is induced with the surplus money from the reduced cost, the net environmental impact may increase or decrease depending on the next activities. And this sort of the effect of the called the rebound effect. LCA that also evaluated these effects are generally called consequential LCA, but there are few LCA case studies that consider these aspects. However, in the real world we live in, it is important to plan the measures while taking such indirect effect into consideration. Special care should be taken when evaluating products that are using the energy. Innovations and improvement can significantly reduce the energy consumption of products. The figure is an example of a car, but we can see that repairing and using an old car for a long time will have a greater environmental impact than the purchasing a new energy-efficient car. Finally, we evaluating CEs, we often evaluate the futures. Each scenario requires creation of an inventory database as shown in these figures. Many LCA case studies of CE already exist, and there are mixed results. It is important to conduct robust evaluations. Extending the boundary of current evaluation is also important, such as indirect effect, value, efficiency improvement, time access, and so on. Banking up good CE approach which have a clear environmental benefit with economic incentive is also important, because environmental benefit alone will not help to spread to that approach. Thank you very much.
Okay, thank you very much. And I think all four speakers, the presentation successfully ended. So now I think it's time for discussion. And first of all, I'd like to invite everybody, our four persons, to make some discussion with each other. So would you please raise your hand or if you have any question to somebody? How about, do you have any? Okay, so go ahead, please.
I have one question to Tahara-san.
Tahara-san.
So I also, it is very important to analyze LCA. But right now, so LCA is not so easy to evaluate for the expert. It's not for the unexpert. So how do you think? So this situation. So we need all we need to know the LCA evaluation.
Thank you very much. So I think, I don't think so. So LCA is just only the plus and the very not so difficult equation. But sometimes it's a very not difficult. It's very, how to say, very complicated and very, how to say, very flexibility was very high. So then everybody thinking about this way is okay or not. But the judge is very difficult. So I think it's if everybody want to estimate to the LCA, so I think first, I will, or you will, the many person in the calculating the result, and then please ask everybody. So then it's LCA there is no answers, I think. So then it's 70% or 80% is agree. That is okay. So I think it's difficult, but the difficulty is to the presentation or on the publication. So then it's please don't hesitate to the open. So and then discuss about something. That is a very important thing.
Thank you very much.
Okay. So any other questions? Or raise your hand. No. All satisfied? Yes, please. Edgerton, those. Mr. Edgerton.
Yes, also I have a question for Tahara-san. A lot of what we see in the life cycle assessments around products, often they go from cradle to gate and end at the point of sale or even after use. Very rarely do we see life cycle assessments that account for the environmental impacts of disposal. A lot of that is due to the fact there's not a lot of certainty where those products wind up. But after accounting for some of the environmental impacts of being in a landfill, of leaching, of winding up in the environment, whether that's air pollution, water pollution, and health or human health or environmental health impacts. A lot of this is often left out of the scope of life cycle assessments as we see them. Do you see more work or focus on the after point of sale within the scope of life cycle assessments that begin to have a honest discussion around what are the impacts on ecotoxicity, on eutrophication, and things like that might just be crowded out of other LCAs?
Easy to answer.
It's quite difficult question.
Yeah, sorry.
Yeah. So just now, in Japanese cases, we are focused on only the greenhouse gases, CO2 or other kind of the GHG emissions. So, but I know, so it's everybody knows, so every environmental impact is a very important thing. So, just now we are LCA already have 50 years old. So, but I think it's just starting point. So we have to discuss about this. So many issues. So just now in Japan, only the one issue in the global warming, but more, I'd say, more talk about this, more many issues that we have. This just starting point, I think. Boom. I'm sorry, not so a good question answer.
No, that's a good answer. Thank you.
Yeah.
Okay, any questions? We have still enough time. So, no question?
So one more
Okay.
question. So,
Yes, go ahead.
I'm sorry, Tahara-san. So the online using LCA, how do you evaluate land filling? Land filling.
Land filling. I see.
So for the CO2 reduction, the land filling is the best solution. In the case of the plastics. So how we can judge reduction or?
So in the Japanese case, is in the environmental issues is the starting point in the waste management. So I think is in the Europe is our landfill is not so high. So there is something land occupation, then not so big issues, I think. So in my sense, but so yeah. So and then for the west is there is some liquid metal or something like that. So then that's a serious problem. But in the Japanese case, there is not so much land. So then we are focused on the only waste management. But my opinion is in Japanese case is a very special case, I think.
Okay, is that okay?
Yeah.
So, so any questions to anybody? If no, I'll make one question to everybody. So I think if we try to reduce, say, environmental burden caused by any product, then I think the most effective way of doing is elongate lifetime of any product. What do you think about this? So long life products, and we continue to use the same thing, and if boring that product, so this product will be moved to the next person. This kind of thing. Yes, please. So,
I can do the first shot. I'm sure the other panel members will have also their views on this. Of course, for me, extended lifetime of a product is part of a circular economy because we're talking about using as little virgin materials as much as possible, avoiding waste, and therefore by using, extending the product lifetime in terms of use, instead of buying new things, it's part of a circular economy to say. One would need to think about consumer behaviors in this respect also, because we also need to shift our mindset in terms of what products can we actually do we want to use longer. I think that Tahara-san here also made a point about the functional unit value in his presentation. So I do think that extended product lives is important. I also still would stress the recyclability of it. So even when we have, extended product life, can we also recycle it and give it its second life still?
So that's true.
And continue to look. There will be maybe some restrictions in terms of the materials, but I believe that if we want to break away from the use of virgin, and in my case, representing a plastic company, crude oil here, and move to plastic waste materials, we would like to have those products back and see if we could develop new products even after an extended product life cycle, to say. So there's a number, from my point of view, of alternatives that we can use when building a circular economy. Extended lifetime, using waste materials, moving on bio-based, and so on. And it will depend on consumer industry behaviors as well as the particular market applications.
That's true, yeah. So, of course, we have to make a very different type of market system. Otherwise, circulation is not so realistic, I think. But sooner or later, I think the world will go to that direction. Probably very simple solution for circular economy, I think, and to elongate the life of the Earth. Do you have any opinion? Yeah, please.
I think Tahara-san already explained a good suggestion. So it means that I think each product has an optimum life.
Yeah.
So please imagine if you own the classic car. In that case, to owning the classic car, for owning a classic car, we need a lot of energy and money. Yeah. So in that case, it is a not good choice. So he already explains if the apparatus or car consumes the energy, in that case, we always think about the efficiency improvement. So I want to say that each product has the optimum time, optimum lifetime.
I see. Well, of course, must be so, and also. The nature of human being is something different to that kind of a long lifetime of the products. But I know, but so I think I read some recent book but some United States some makers or some maybe merchandise probably they started to test such kind of things. So I think it's very gorgeous clothing. So, but it's of course a long time, a lifetime is long enough, but it's boring. So we are 2 or 3 times they're boring. So it's very expensive. So then, so the user can sell back to that company, and this company will sell the used one to the next one. So this kind of thing. So I know that someone United States merchandise is going and successfully. I think so. That certain things. So even if automobiles are also. It's a machine, so the lifetime is there. But so I think one more example is that if we can detect the real lifetime by observing more, for example, for the vehicle, probably the bearing can be not the weakest, but anyway, the weak part of the machine. So if we can detect the lifetime of bearing by hearing noise or measuring temperature or some kind of other things, then probably, sooner or later it will go bad. So then, we can maintain that, so exchange that, bearing that. Those such kind of things. Probably there's several ways to extend the lifetime of all products, I think. So probably consumers' attitude may not be go that way, but if so, we have to elongate the life cycle, the lifetime of the Earth. Probably we have to do something like that. So that's my now I think so. So, but probably business may be very difficult.
Point that at some point you want the longevity of that product to be designed to meet the intent, right? That you don't want the product to be incredibly durable and long-lasting. That, to Lynette's point, that it can't be recovered or recycled, or that if it gets out of the economy, that it lasts forever in nature. I think there's also a point at which durability isn't helpful anymore. But having an understanding of how you want that designed and the system that it's going into to allow for that optimal performance is the ideal scenario. And it kind of brings up the other question is, what is that optimal lifetime? And is that up to the consumer, or is that up to the business? As we switch more towards circular business models and thinking even as product as a service, what could be an optimal lifetime for a business is very much different than an optimal lifetime for a consumer. Or just, particularly if you are providing upgrades or updates on systems, but the company still takes that original product back to use in the next cycle. Unfortunately, I think the most common answer you get in asking, which is better in a comparable LCA, the most frequent answer you get is it depends. Is also the case here, where one factor is the energy intensity and amount of environmental impacts going into the production of that product. I would argue that you also need to account for the potential environmental impacts or consequences of its disposal and afterlife, and then thinking about how long who at the end of the day owns that product, and for that situation, what is the most ideal lifetime duration?
Okay, thank you very much. And so now we have 13 minutes to go, is that so? And we have several questions from listeners. What can we do that? Or still somebody, any question to the other presenters? It's okay? Okay, then probably I read a question to you, and which one is good? Someone says that, so this is a question. According to the presentation, the global circularity is still below 10%. Do you think what is the most important driver to penetrate this? So that, is that real? I don't know that reality. Global circularity is still below 10% or so. Is that so?
Yeah, maybe I'll step in here because I think that was out of my presentation.
Yeah.
There was a report that's issued on an annual basis by a group in the Netherlands called Circular Economy. And their report is the Circularity Gap Report. And it estimates the global circularity of the past year. It was actually 9.1% a couple years ago, and dropped down to 8.6.
I see.
This year. So it's heading in the wrong direction. And to be honest, it's not completely surprising because of the larger trends we see. One, population is growing. Two, in general, more people are being able to buy more things, and that's coming in different parts of the world. And then also, the other image I showed that material productivity is no longer climbing. That we, for all of the GDP that we have, we're not using the total resources as effectively as we were before. So all of this lends itself to an understanding that it's probably expected that we wouldn't be that circular. I would argue that number, our total circularity, was probably quite high pre-industrial revolution. And as time went on since the Industrial Revolution, that number has dropped to where it is today. and it will take a number of different circular strategies and commitments from business and the public sector in order to start getting that number up. It will have to be a concerted effort. It will, we won't be able to make much difference if we just try and improve recycling. That, as Lynette mentioned, thinking about design of the products in the very beginning is a critical element. Thinking about the end consumer and how they're going to use it and what they can do with it after. And ultimately, new business models are all going to be required in order to change that behavior. But it's certainly a situation where business, government, and civil society all have a role to play in progressing the circular transition. Some will have bigger roles than others, but it's I would say quite accurate to where we can anticipate to be. And there have been academic studies that have come after this report that more or less show the same order of magnitude, which I think is the important element here.
Okay, thank you very much. And so can I go to one more question from our listeners? And probably this is okay. So どうしようかな、田原さん。This okay. I'll read the question. Are there any international mechanisms that enable comparison of different systems in different countries? So that I think they are talking about a circular system. So probably, say, waste management is quite different country by country. So, but he would like to know that international mechanism of enabling comparison. So, what about Tahara-san? Do you know something?
Yeah. So ISO in life cycle ISO is we don't not so comparable. So it is very high level, very high hurdle. Yeah. So
others high. Okay.
So but everybody want to compare. So A products and the B products, which is better. So and then, but it is quite difficult, for the other country and my country, or for the Europe and Japan. Is we will, yeah. So and then there is the data is a bit quite different. And then in the situation of the society or something, so then is that we can it's not so easy to compare, I think. So yeah. So in database area is that we got talk about is that we want to share to the data each database. So in the European database and the Brazil database and the Japanese database in the other country database. So we want to share. So in a UNEP is UNEP organizes the GRAT system. So and then in the first step is that we can share to the data, and then so we can compare to the each data, and then so in the case study we want to so but it's a very high so very high mountain thing. So but we have to do that. Yeah.
I see. Is there any possibility to read Japanese people to go to that direction?
I want to. So in my study is we have IDEA's database, so Japanese database. So of course, it's a Japanese company go to the abroad. There is a factory in the Asian country or something. So they want to use in the Asian countries inventory data. So, but it's unfortunately not so much. So just now you are released to the in the estimation is adaptation data for the each country based on the Japanese database. So that is a very first step, I think. So then we will compare to which country, which product is more better. Yes. which circular economy system is more better.
Okay. So I think it's about time to close a little bit earlier. Still, we have some time, some minutes, but well, the presentators, do you have any more questions? No? If not, so probably I'd like to thank our presentators and a very interesting meeting. And but probably I have still have a feeling that the circular economy means so many things, probably. So what kind of circulation really, or what kind of merchandise we should circulate, or something. So anyway, probably we need more detailed discussion in the future. So I think this meeting will contribute to some extent to see the future of circular society or circular economy, or anyway circulation, and also what is a good way of doing to extend lifetime of this earth. I think this is I'd like to conclude this session. And is that okay? Okay, then. Thank you very much, everybody, every presenters. So good luck for you. See you later. Bye-bye.
Thank you.
Thank you very much.
Thank you very much.
Thank you very much.
Thanks.